So in 11.2 we had permutations, 11.3 is combinations. So these two things are different. They're very similar though. So let's talk about the characteristics of a combination. So first of all, the items are selected from the same group. Well, that's the same as a permutation. So that doesn't change how you do that. Second, no item is used more than once. That's also the same as a permutation. The biggest difference is that the order of the items makes no difference. So with permutation, we discussed that, if you're taking three-digit numbers, let's say, if you use the numbers 1, 2, 3, 1, 2, 3 would be different than 3, 2, 1 in a permutation. So this would be two different arrangements. In a combination, you're just grouping things together. So 1, 2, 3 is the same group as 3, 2, 1, same digits that are grouped together. So you wouldn't count this twice in a combination. So that's what the difference is between these two arrangement-making formulas. So the first thing you need to be able to do is distinguish whether a problem is going to be a permutation or a combination. Sometimes you're going to be told, but sometimes you won't. You're going to have to figure out when you're supposed to use the right formula. So in the first one, it says 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second biggest vote getter becomes the vice president. And the student who gets the third largest number of votes will be the student government treasurer. How many different outcomes are possible for these three positions? Okay, so you're thinking to yourself, is this a permutation or a combination? And then think about the difference between what a permutation and a combination is. Okay, the biggest question you want to ask yourself is, does order matter? You think it does? And
the biggest vote is going to be something?
Right, so you have a first place, a second place, and a third place, right? There's an order that's being defined here, and the order matters as to who gets what position. So yes, you're correct. Order matters, which means permutation. Good. Okay, so yeah, so the order in which the officers are chosen makes a difference. And so order matters, and that means it's a permutation. In a combination, order doesn't matter. You're just grouping things together, and the order in which the group has been chosen does not change the group itself. Okay, so that is a permutation problem because order matters. Okay, and that's the biggest thing you want to make note of is order matters, permutation. So here's another example. 6 people are on the volunteer board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people on the board of supervisors? Okay, so take a minute to think about it. Is this a permutation or a combination? Okay, so combination, because order doesn't matter, is correct. Good. So a 3-person committee is to be formed from 6. The order in which the 3 people are selected does not matter because they are not filling different roles on the committee. So it'll be the same group of 3 people no matter how you pick the people to join the committee. All right, so order makes no difference, or order doesn't matter, however you write that down. And so it's combinations. Baskin-Robbins offers 31 different flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Okay, so take a moment to think about it. What type of problem do you think this is? So think about that. Okay, so once you've chosen a flavor, you can't use that flavor anymore, and that's correct. So then the question you're asking yourself, okay, so let me go through the explanation here. So if you have a bowl of chocolate, vanilla, and strawberry, in the order that you actually scoop it into the bowl, it doesn't matter, okay? It's the same 3 flavors that are in that bowl. Now, I know some people have their preferences. If it was me, I'd want my favorite on the bottom because I want to end with that, you know, and then the next one, okay. But as far as how many bowls can be created, order doesn't matter. And so, therefore, this is a combination as well. Okay, so good job. All right, so recognizing what type of problem it is half the battle. Because if you don't know what type of problem it is, then you won't know which formula to use to solve your problem. So make sure that you're really paying attention to what these types of problems are. Now, the more you practice your homework, the more familiar you're going to be with these types of problems. All right, so looking at the combination formula, it is almost exactly like the permutation formula, but there is one additional thing in the denominator. So this time we're going to use a capital C for combination. It's still n factorial up top, and we start out with the quantity of n minus r factorial, but now we have another r factorial in the denominator. By dividing by that extra r factorial, that's going to take in account the ones that we're not going to count twice because the order is different. Okay, so it divides out all of those other ones that are really the same group in a different order. Okay, so first example, while studying abroad one semester, Tran is required to visit 10 different cities. He plans to visit 3 of the 10 over a long weekend. How many different ways can he choose the 3 to visit? Assume that distance is not a factor. Okay, so you're going to ask yourself first, does order matter on how he visits the 3 cities? No, order doesn't matter. It doesn't say that it's important that he goes to this city before he goes to this city, and so on. So order doesn't matter. You're just deciding, okay, these 3 cities, and then later we'll decide what order we're going to go visit them. So it's a combination. So we're starting out with 10 factorial over 10 minus 3 in parentheses factorial, 3 factorial. Okay, so on the formula down there where the capital C is, I just noticed that my 10 is sort of hidden in the shadows there. So, you know, just be clear, there's a 10 there. All right, so order of operations says start where there's parentheses. So what's 10 minus 3? 7. So on the denominator, you really have a 7 factorial and a 3 factorial. What do you notice about the 2 numbers in the denominator when you compare them to the number in the numerator? They add up to the numerator, yes. 7 and 3 add up to 10, and that's going to happen every time you have a combination. The 2 numbers in the denominator should add up to equal the one in the numerator. So that's a little self-check to say, okay, if they don't add up to the top number, you know, oh, wait, I must have subtracted wrong or written something wrong in my formula, and so on. Okay, so, excuse me, so we can expand this out, but notice that as I start counting down, 10, 9, 8, 7, notice that the 7 and beyond will cancel with that 7 factorial. Okay, so notice that the majority of this is going to cancel up top. So you only really need to count down to the highest number in the bottom. But then you still have to expand out the other factorial in the denominator. Okay, so here's how I've written it. 10, 9, 8, 7 factorial. And then I put that other 7 factorial on the bottom at the end just to show that those are going to cancel. I could keep writing those out. I could do 7, 6, 5, 4, 3, 2, 1. But then I'll be doing the same thing on the bottom, 7, 6, 5, 4, 3, 2, 1. It's going to cancel anyway. So it's just a shorter way, so you don't have to, do too much there. But we still have to expand out the 3 factorial, which is 3 times 2 times 1. All right, we definitely know that the 7 factorials will cancel. Okay, 3 goes into 9 3 times. And then 2 goes into 8 4 times. Okay, I got a little ahead of myself on the clicking there. And your answer is 120. Okay, 10 times 3 times 4 is 120. Now, I'll point out that some of you guys have calculators that have shortcuts on how to do this. I'm not going to show you how to use the shortcuts, but I'm not going to police you either. But do keep in mind that there will be some problems where the shortcuts in your calculator don't work. So you need to make sure you understand this concept of factorials and knowing that it's multiplying each of the preceding numbers that come after it, okay? So one example that I can give you was from 11.2. Do you guys remember that there was the formula of items if they're duplicated? And it was a totally different formula, and that one doesn't have a shortcut in the calculator. So you have to make sure you understand how to simplify these factorial problems. All right, so any questions on this particular one? So this means that there are 120 different groups of 3 cities that he could go visit. There's 120 different ways that he can decide on what 3 cities he's going to do that weekend.